So in this video, we are going to talk about continuity and discontinuity of a function. Now let's start off with continuity. So a function is said to be continuous at a point A if and only if 1. The function is defined at that point, that is, the function is defined at A. So we say that f of A is defined to the general limits of the function f of x as x approaches A exist. Now with that, it means that the left hand limit is equal to the right hand limit. So both the left hand limit and the right hand limit exist and they are equal. And then thirdly, the general limit of the function f of x as x approaches A is equal to f of A. Now for a function to be continuous at a point A, all these three conditions must be satisfied. Now what this primarily means is that if even one of them is violated, then it means that the function cannot be continuous at that point. Then we say that the function is discontinuous at the point A. Now before we talk about discontinuity of a function, we should understand that a function can be continuous only at one side. So let's say if the left hand limit is equal to f of A, then we say that the function is left continuous. So the function is left continuous. And then B, if the right hand limit is equal to f of A, then we say that the function is right continuous. Now let's move on to discontinuity of a function. Now a function is discontinuous at a point A if it is not continuous at that point. Now we have three main types of discontinuity. The first one we are going to talk about is what we call the infinite discontinuity. Now a function is said to be infinitely discontinuous at a point A if either one-sided limits do not exist or is infinite, or better still, both-sided limits do not exist or are infinite. Now what this primarily means is that if either the left hand limit does not exist or is infinite, or vice versa, that is, the right hand limit does not also exist or is infinite, or both-sided limit, that is, the left hand limit and the right sided limit or the right hand limit, they both do not exist or are infinite. Now if this happens, then it means that the general limits of the function as x approaches A does not exist, that is A. And then B, if f of A is not defined. If f of A is not defined. Now let's move on to the second one, that is jump discontinuity. Now for jump discontinuity, both the left hand limit and the right hand limit exist and are finite, however they are not equal. So the left hand limit and right hand limit, they both exist and are finite, but not equal. they are not equal. So we say that left hand limit is not equal to the right hand limit, and thus the general limit of the function as x approaches a does not exist. And then b, f of a is defined. So for a jump discontinuity, f of a is defined, however the general limit of the function does not exist. 3. Now to removable discontinuity, the left hand limit exists and is equal to the right hand limit, which means that the general limit of the function as x approaches a exists. However, the general limit is not equal to the functional value, or better still, is not equal to f of a. So basically, this is the introduction to continuity and discontinuity. Now let's move on as we solve a couple of examples. So let's try these questions. Determine the numbers, if any, at which the given function is discontinuous. Here we have two questions, 1 and 2. So let's start off with 1. So we have f of x equals x squared minus 16 divided by x minus 4, where x is not equal to 4, and then 10, where x is equal to 4. So let's solve this question together. Now to prove whether a function is continuous at a point, first of all, we know that f of a should be defined. So f of a, it should be defined. And then secondly, the left hand limit should be equal to the right hand limit, and thus the general limit of the function exists, and the general limit of the function should be equal to f of a. So for a function to be defined at a point a, these are the three conditions that need to be satisfied. So now let's move on to this question. Here we have x not equal to 4, x equal to 4. So we are going to investigate whether the function is continuous or discontinuous at x equals 4. Now from the function, we have f of 4, and that is equal to 10. Now this means that f of a is defined. It means that f of a is defined. Now, since we have x not equal to and then x equal to, it means that we are not going to find the left hand limit and the right hand limit. We are basically going to find the general limit of the function. Now we have the function x squared minus 16 divided by x minus 4. That is when x is approaching 4 but not equal to 4. So now let's pull out this function and try to work on this function. So we have the function x squared minus 16 divided by x minus 4. Now we have the numerator to be a difference of 2 squares. So we can expand this as x minus 4, x plus 4 divided by x minus 4. So we cancel out x minus 4, and then we are left with x plus 4. Therefore, we have the general limit of the function x plus 4 as x approaches 4 is equal to, now basically we are going to substitute 4 into this limit. We have 4 plus 4, and that is equal to 8. So the general limit of this function is equal to 8. Now notice that the general limit of the function f of x as x approaches 4 is not equal to f of 4. Now since the general limit is not equal to f of 4, it means that the function is discontinuous. It is discontinuous at x equals 4. Now, what type of discontinuity are we talking about? Since the general limit of the function exists, which is equal to 8, however, it's not equal to the functional value f of 4, it means that this is a removable discontinuity. Now, let's move on to the second question. So for question 2, we have f of x equals 3x plus 5, where x is greater than or equal to 2, and then x squared, where x is less than 2. So first of all, let's find f of a. So that is f of 2, because we have 2 and then 2 here. Now f of 2 is found in this domain because we have x is greater than or equal to 2, which contains 2. So for f of 2, we are going to use this function. So that is 3 times 2 plus 5. 3 times 2 is 6. 6 plus 5 is 11. So we have f of 2 to be equal to 11. So f of 2 is defined. Now, since we have greater than or equal to and then less than, we are going to find the left-hand limit and the right-hand limit. So for the left-hand limit, we have the limit as, which function do you think we are supposed to use? Now, we are talking about the left-hand limit, which means that we are going to consider x less than 2, which is the function x squared. So the limit as x approaches 2 from the left of x squared is equal to 2 squared, and that is equal to 4. Now for the right hand limit, that is x greater than 2, so we are going to use this function. So we have the limit as x approaches 2 from the right of 3x plus 5. So we substitute 2 into this. We have 3 times 2, which is 6 plus 5, and that is equal to 11. So the left hand limit exists and the right hand limit also exists. However, the left hand limit, even though it exists and it is finite, is not equal to the right hand limit. Now, since they are not equal, it means that the general limit of this function as x approaches 2 does not exist, and hence the function is discontinuous at x equals 2. So even though f of 2 is defined, since the general limit does not exist, it means that the function is discontinuous at x equals 2. So what type of discontinuity is this? Because the left hand limit is not equal to the right hand limit, and then the general limit of the function does not exist even though f of 2 is defined, it means that we have a jump discontinuity. Now to question 3. Determine if the function is discontinuous at x equals 1. Now we have the function f of x equals x squared divided by 2, where 0 is less than or equal to x is less than or equal to 1, and then 2x squared minus 3x plus 3 over 2, where 1 is less than x is less than or equal to 2. So let's try to solve this question. So the first thing we are going to do is to find f of a. So here we have at x equals 1, so f of 1, and that is equal to, now we have this domain to be close bracket 0, close bracket 1, and then this to be open bracket 1, close bracket 2. So f of 1 is found in this domain, so we are going to use this function. So that's going to be 1 square over 2. 1 square is 1 divided by 2. We have 1 over 2. And we know that this is defined. So f of a is defined. Now, since we have less than or equal to, less than or equal to, and so on and so forth, we are going to find the left hand limit and the right hand limit. So let's start off with the left hand limit. So we have the limit as x approaches 1 from the left. Now looking at the interval, you realize that if you want to talk about the left side of 1, then you are in, or you are within this range. So this is from 0 to 1 inclusively, and then the left of 1 is within this interval. So we are going to use this function. So that is the limit of x squared over 2 as x approaches 1 from the left. And that is equal to, we put in 1. So we have 1 squared over 2, and that is equal to 1 over 2. Now for the right hand limit, we have the limit as x approaches 1 from the right, and then if you want to talk about the right side of 1, then that is found in this interval. So we are going to use the function 2x squared minus 3x plus 3 over 2. Let's plug in 1. We have 2 times 1 squared minus 3 times 1 plus 3 over 2. So 1 squared is 1, 2 times 1 is 2, 3 times 1 is 3, and then plus 3 over 2. Now 2 minus 3 is negative 1, and we can think of negative 1 as negative 2 over 2, and then we have plus 3 over 2. Now we chose to write negative 2 over 2 because we had this to be 2. That is, the denominator of 3 over 2 is 2. Now since the denominators are the same, then we can basically simplify the numerators. So that is negative 2 plus 3, and that is 1. So we have 1 over 2. So the right hand limit is equal to 1 over 2. Since the left hand limit is equal to the right hand limit, it follows that the general limit of the function as x approaches 1 exists and is equal to 1 over 2. Now, since the general limit of the function as x approaches 1 is equal to f of 1, it means that the function is rather continuous. The function is continuous at x equals 1. So to question 4, we are going to find the value of a, for which the function is defined below, assuming that f is continuous at x equals 1. So we have the function f of x equals 2ax minus x squared plus 3, where x is less than 1, and then 3x where x is greater than 1. Now looking at this function, you realize that the function is not defined at x equals 1. Neither is the function continuous at x equals 1. It means that the function itself is discontinuous at x equals 1, because we don't have x equals 1 in this function. Now from the question, we are just going to assume that the function is continuous at x equals 1, even though it is not literally continuous at x equals 1. So let's try to solve this question. Now if we are going to assume that the function is continuous at x equals 1, then it means that the left hand limit is equal to the right hand limit. It means that the limits of the function f of x as x approaches 1 from the left is equal to the limits of the function as x approaches 1 from the right. So now let's find the left hand limit. So that is considering x less than 1, we are going to consider this function. So that is the limit of 2ax minus x squared plus 3 as x approaches 1 from the left. That is equal to, let's plug in 1 into this limit. We have 2 times a times 1 minus 1 square plus 3. Now 2a times 1 is 2a. We have negative 1 and then plus 3. So negative 1 plus 3 is 2. Therefore, we have 2a plus 2. Now, let 2a plus 2 equals L1. Now to the right hand limit, we have the limit as x approaches 1 from the right, and then we are going to consider the function 3x. So that is equal to, plug in 1 into this limit, you have 3 times 1, and that is equal to 3. Now let this limit be equal to L2. That is, the right hand limit is equal to L2. Now, since the left hand limit is equal to the right hand limit, it means that we have 2a plus 2 equals 3. We transpose 2 to the right hand side. We have 2a equals 3 minus 2, and then 2a equals 1. So we divide through by 2, and then we have a equals 1 over 2. So the value of a is 1 over 2. So if the function is assumed to be continuous at x equals 1, then it means that the value of a is equal to 1 over 2.